Okay, so today is the 24th. Renos, you wanted to ask about multi-headed model functionality, and someone wanted to ask about PettingZoo integration, and Simon, you wanted to ask about DDPO. Okay.
For the multi-head, one of the issues is that you need to essentially separate the experiences from each type of environment. You need to separate them in the replay buffer, and then
So you need multiple replay buffers is what you want to do.
essentially, yeah.
Because you need to sample evenly from your tasks.
Mm-hmm.
Okay, cool. I have dealt with this before. I used to do research in multitask and meta reinforcement learning.
Okay, cool.
Okay, so okay, so essentially what you would do is like you would create your own policy class, in this case, like overloading whichever algorithm's policy you want to overload, or you can also directly inherit from this class called torch model v2, which is like the base policy. Well, sorry, no, not torch model v2, but torch policy. And like that's sort of the base class for our policies, and it like directly inherits all the methods that you need. After that, like what you would do is you can define your own custom model over here. So you could say like just like self.model is equal to, in this case, like it would be like a PyTorch model that has like multiple heads. Okay. And then when you call .forward, you have some way in order to like select which head it is that you're gonna utilize in that situation. And then with your loss, it would also go pretty similarly, if I understand this correctly. It's like you would have a loss that specifically propagates like through your different heads.
Hey, Avnish, which version is this?
Of Ray?
Yeah.
This is like currently master. Yeah, the stuff that we're implementing for this like new connectors API, it's gonna be on master. You won't be able to find any of it in 1.12. You will be able to find it in 1.13 though. Renos, if you're like still looking, you would define a you define a model, and this is actually like where you would implement like the glue logic of your multiple heads. Okay, yeah. So like over here, you would like this class inherits from both torch model v2 and nm module. Not entirely sure in this case like why we felt the need to inherit from both, because this inherits usually directly from nm.module.
Yeah, I've seen that too.
So when you do this, you have to declare an attribute called self.model. In this case, I think like we include something so that like you can create like a set of like fully connected layers that directly interface with your observation space and action space. And then in this case, like they're using the centralized critic across multiple policies. And they create something here called a central VF. Yeah. And then, are you using Torch, by the way? I'm sorry, I forgot to ask.
Yeah.
Okay. Yeah, so you would implement
I've
your
used Torch and also Jax in the past, but it seems Jax support is supposed to come in the next couple of months, I believe, right? At least there was talk about that a couple months ago.
We want to do it. The only thing is that there also has to be like an implementation essentially of all of the distributed training infrastructure for Jax, which like Jax doesn't technically support out of the box. So we have an intern on the RAID train team who's working on that right now. So basically whenever he figures that out, we will also migrate a lot of our algorithms to Jax and eventually drop TensorFlow 1 support. in your forward method, you would probably have to specify something that specifies the head that you're gonna actually be using.
How flexible are things for me to add extra arguments to like forward for a model?
You can actually add extra arguments to forward for a model because you're also going to be the one who calls forward for your model.
Yeah, that's true.
If I understand it. Well, I mean, like you definitely will have that flexibility. I'll let you know. Yeah.
Yeah, because one of the things I've been having some trouble with is then when it comes to calling the policy like during tests. Well, not necessarily during test time, but there's, let me bring this up. There's like a whole rabbit hole you need to go through to actually calling your model.
Oh yeah. Okay. Do you want to share your screen and show me what it is that you're talking about?
Apologies, I have some noise in the background a little bit. So
No,
just as an example, there's a couple of functions that there's like compute single action and then compute action helper. And then it's only like down here that you actually get into the model itself. So, and then that's in the actual policy itself.
So I guess my question for you then is like, why would you not just why would you just not override the compute action of the policy that you're inheriting from? I mean, you should just be able to overload compute action directly, and then, you know, so long as compute action takes in whatever parameters like it's typically supposed to take in this case, like I know that a sample batch will be there. What I would probably do if I were you is like I would stick the task ID somewhere inside of minfos, or I would stick it like in another attribute. You can arbitrarily expand sample batches however you want, and then I would feed that then to my model.forward, and then inside my model.forward I would use like some torch conditional to select whichever head I need.
Right.
Yeah.
So then the only other thing is the multiple buffers, and essentially how to
how to actually do that, right?
How to actually feed into those, because I think the best way to set up the multiple environments is through the task settable environment, but then how do you interface that with
the replay buffer?
Yeah.
So are you using PPO as your base algorithm, or are you planning on using another algorithm?
I'm trying to get IMPALA and RTD2 to work as well.
I'll show you with IMPALA just because we have replay buffers over IMPALA.
Yeah. Oh yeah. I mean, if I were to switch to this, I wouldn't be using PPO since PPO doesn't use a replay buffer. So
it doesn't directly use a replay buffer. Yeah. So you'd probably not want to do that.
I mean, it's on policy, right? So
yeah, it's on policy. Yeah. You can use this thing called Mixin Replay though, which is like what IMPALA does. That's what the replay buffer is for. Yeah. So I guess a couple of things. Let me think. So the first is like I haven't used the task settable end, but like, how has task context actually changed? Is it just changed on every single environment iteration?
Each episode, yeah.
Each episode. Oh, okay. Give the context too much, but okay, sure. Okay, but like, how do you know which task you sampled from? That's I guess is like my question. Is it like a part of the minfos, or is it like how do you return like which? So like if I don't know, if my tasks are like different Atari tasks, how do I know which environment it came from?
So I can show you the actual API.
Okay.
I'm pretty sure I'd have to add some sort of mix in at the end because you can. So there's three functions: sample task, set task, and get task. I'm pretty sure you'd be able to call get task like at the end of an episode.
Okay. Oh, use this for mammal. Okay, that makes sense. Okay, so if I just search up like get task. Okay, so you pass this task function to the trainer, and then the task function figures out based off of the result whether or not it should switch to a new task, and then you get the current task, and if the current task is not equal to new task, you set the task to the new task. Okay. Cool. I guess that makes sense to me. The only thing is,
Yeah,
you
it
still
feels
need
like
to
the
wait.
original was meant for curriculum training, which makes sense for curriculum.
Yeah,
learning.
it makes sense. It was made for like meta learning, using like random goal, half cheetah random direction, pendulum with different masses. Okay, so the only thing is we just need to look at like a task settable and overrides chim.env. Okay, so you still definitely need something in order to figure out like what task you actually are going to be operating on, just because you have multiple heads. So like this isn't a challenge in meta learning, just because it like in meta learning you're not supposed to have access to that information.
Yeah.
So we didn't technically support it. So step one is like add something to your admin post, just because like otherwise there's not going to be any way to figure out which task you're directly inheriting from. And then now for replay buffers specifically, let me share my screen again. This is actually not too bad. So do you, so I guess my first question for you is like, do you pip install Ray and then like try to inherit stuff and then implement it? Or have you just cloned the repo and then you've installed it and then you're working
I
inside
pip
of it?
install and inherit.
You pip install and inherit. Okay, cool. So say you're working on Impala, okay? Like you want to implement the Impala agent. You could say like from ray.RLlib agents impala import ImpalaTrainer and then class multitask learner. That'll extend the ImpalaTrainer. But we're still going to need to read the Impala code here to understand like where it is I would actually stick a custom replay buffer. So in Impala, we have like this dunder init function. You're actually not going to touch this just because like this is not what you need access to in the situation. Okay, so this is some stuff for like, I can walk through this for a second. So this over here is like these config objects that we've created because users typically struggle to
I
use
saw that
like the
yesterday.
config dictionaries. Yeah, we're not replacing the dictionaries, we're creating an interface on top of them. So you can still use the dictionary directly. But just because that gives people like a lot of flexibility when they're designing their own APIs on top of RLlib, but
yeah,
this should still make life easier. So if I come over to Impala, the first thing is like, in this case, like you would stick your own policy class in here where it says get default policy class. So I'd say like, be like, so I'd stick my own policy class here. I just returned. Second thing though is that like you want to know about like how I would actually implement separate replay buffers. So there's a setup function, okay? And in this setup function, this is typically where we we provide all of the, or like we instantiate all of like the necessary objects for your experiment. Okay, like this is actually how I designed it. So I guess I'd first like call def setup and name, and then I'd say like ImpalaTrainer. So you definitely have to call super.setup just because like this will create all of this extra stuff that you need in order to run Impala, or you can just copy this also, which is fine in this situation. It would require like a little bit of reading to understand all the extra stuff that's happening underneath over here. So for example, like we have these replay buffers that you do Mixin Replay on, but we also like provide the option for them to be like separate actors that can essentially work in parallel to your experiment. And the reason that we do this is because we give users the options to like compress their observations. And this is particularly important in the situation where you are like working with these observations that are like these large 3D point cloud maps, or just like really large images and like quite a few of them. And so like the compression and decompression steps can take a pretty long time. But like if you do them on separate workers, like you'll see like quite a significant speed up. Okay, but in essence, like there's something over here that we use to create replay buffers. And if I go over to like the simple replay buffer.api, yeah. So the simple replay buffer has like an add function and it has a sample function. Okay.
Mm-hmm.
And in the scenario of like that you're wanting to use Impala, which uses a Mixin Replay, so that would be the case for you doing an on-policy algorithm. It's like if you want to have replay experience, but then also like you need it to be on policy, you would do this thing called Mixin Replay. I can explain it to you if like you want to know what that means. In a nutshell, we mix in some of our current on policy examples with like a couple of off policy batches. And we do this just so that like we don't like hit these we don't hit these weird exploration states in during our training. Like this is just something that typically happens like in on policy learning. And then yeah. So okay, if I come back here really quickly and I go to multi-agent Mixin Replay Buffer. So there's an add batch, which just takes in a generic sample batch, and then there's sample, which takes in like a number of items to sample. So in the case of your replay buffer, you can like copy the logic from say like fragments over here, because like Impala will work on like replay fragments, but so you can copy the logic over here for add from replay fragments, and then there's actually like multiple replay buffers that are underneath this replay buffer, right? So like we have this attribute over here called self.replayBuffers, and we've designed it currently in the case that like you would have multiple agents in your you would have multiple agents inside of your environment, but you can definitely use this instead to like talk about multiple tasks. And then if you come back to add, then basically what I would do is I would check to see for each one of like the fragments, a fragment in this case being like some amount of like time steps that you collected in an on policy fashion. I would add it by task ID. And then when I come to sample, I'd sample a number of items, and then I guess you can change like number of items to mean whatever it is that you want to. So maybe in this case, you could be like number of items per task ID, or you could mean like the whole sum as a whole. That way you sample evenly. Really just like whatever makes more sense to you. And then I would follow this logic for mixing batches, and then I guess you also, you probably would want to copy this too. This check if buffer is ready. This just essentially checks to see whether like a replay buffer has a minimum number of samples in it so that you can sample from it. So it implements like some of that starting logic from like when you're doing your sampling, but you don't have enough samples yet to do your mixin. And then after that, I would implement the logic over here to sample from these individual replay buffers. And the individual replay buffers are simple replay buffers. So you can just query the replay buffer by task ID, and then you could, I don't know, say like keep around like a dictionary of task IDs inside of your replay buffer too. That way you don't have to keep track of it anywhere else, and then sample evenly from your individual simple replay buffers, like having some task ID. And then when you come back out, you should be able to do it that way.
Yeah, that
So like
makes sense.
this
I think I should be
Mixin Replay Buffer gets called inside of a training iteration function. So like if I go to this process experiences directly, it uses the local Mixin Replay Buffer. And I mean, let me know if this like doesn't make sense to you. Just because I know it's new code that we're reading for the first time here, but so over here, like this is where you would add samples to your replay buffers. If you didn't want to go through the process of like implementing your own Mixin Replay, just because I get that's kind of like a hassle to do, something else I might consider doing is I would create a Mixin Replay Buffer for every single task inside of my task dictionary. And then when I go to process experiences directly, inside of these batches, I can like iterate through the batches and actually see like which batches belong to like a certain task ID. And then over here, like this is where I would query by task ID and then add to like a specific Mixin Replay Buffer.
Mm-hmm.
If that suits you better. I mean, it's actually I'd probably do it this way, just like if I was doing some rapid iteration and I didn't need to make something that was like further extendable beyond this. Does that answer your question, Renos?
Yeah, I think that does. We can probably move on now. I know it's been half an hour, so.
Yeah, but I hope this helps you.
Yeah, no, it definitely did. Thank you.
Yeah, I know like it's not as satisfying that you still do have to dig into the Impala code specifically, but we have done a lot of work recently to make it really easy to read and then just like drop, PDB breakpoints directly within like the scope of your execution. So I hope this helps, but if it doesn't, like please feel free to reach out on the Slack, and
sure.
We can definitely even set up time with you to help you out. Yeah.
Okay, yeah, that sounds good. Thanks.
Okay, Simon, you are next.
Also, Joseph came in. He was in queue before me.
Hello.
Before me in the dock.
Oh, in the dock. Okay. All right.
Can you hear me?
Yeah, I can hear you, Joseph.
I think that I mentioned some of this, Avnish, already. We had some of this discussion on Slack already, but it's just the case that PettingZoo is becoming an increasingly widely adapted project. I'm using it in Neural MMO. It's a great API. It has tons of bindings for other things that people are using in RL. And it seems that it can do just about everything that can be done with the current RLlib API. So it's quite similar, in fact. So yeah, if you want to add some details on that, Jordan.
Yeah, so the main thing is that, PettingZoo's kind of become the standard multi-agent API. It is used as the default API for pretty much all the major third-party environments, like Unity ML agents, for instance, and their massive switched using PettingZoo instead of their custom thing. Tiancha is using PettingZoo. Like literally every meaningfully sized multi-agent RL library outside of DeepMind, which uses custom stuff, uses PettingZoo, and pretty much all the third-party libraries like Smack or whatever do as well. The environments. And so if there's a standard, and so you guys support the PettingZoo API, but if there's a standard API that like all the other multi-agent APIs are using, analogous to Gem, then it's better for the community and saves development costs for RLlib to switch your internal API to PettingZoo, which you already support.
So I do like PettingZoo, okay. But I think our main, we had like a couple of issues with doing the migration. So the first is that like we have customers who do multi-agent reinforcement learning, and we proposed to them the idea of the migration, and I walked them through like how the actual migration would look, and then I had them like go and inspect the PettingZoo API, and I'd say like a split of like 50-50 wanted and didn't want it. And I'd say that like I think the predominant issue is that like it's actually the issue that PettingZoo tries to solve, which like personally I'm a fan of. It's like phrasing all of these as like two-step games, right? So that way like you don't have
two APIs. It has the AEC API and has the parallel API. The parallel API is, for all functional purposes, identical to RLlib's built-in API, and the way that they're constructed is that you can switch between the two pretty much for free.
And to add to that, Avnish, I used RLlib's my main project NeuralMMO, right? I use basically all the features in RLlib. So I will tell you that the migration from RLlib's API to PettingZoo's, it was basically trivial.
Because he's using the parallel version API.
For exactly. So it's very easy to support a large number of environments, either turn-based or parallel.
Okay, that is like one problem that's definitely solved. But I think like a larger thing that we face right now is like we also have these customers who work across all these different operating systems and all these different versions of Python, and like as much as it is like I don't want to call it a burden just because like it is their situation, right? But like in a nutshell, it makes it difficult to support them like when the upstream packages that we use don't necessarily provide that support to them.
So PettingZoo is pure Python. So it'll work on any operating system. The only exceptions to this are so PettingZoo and Jim both, have as extra dependencies things that are compiled in C. All of those support Mac and Linux.
And Linux, yeah.
And most of them support ARM, Mac. That we're working on that, and some of them support Windows, and some don't for the compile things to Windows. So that's kind of uncommon, and that isn't required to use it as a core API. That's a specific environmental limitation, and that's true of Jim and not just PettingZoo. As far as Python versions go, we obviously support 3.7 and 3.10. You mentioned this on GitHub that people are still using 3.6.
People are still using 3.6, yeah.
I'm slightly confused about that.
Like Python. I don't disagree with you, by the way. Like I don't see like a reason why people should be using Python 3.6. It's just that like our customers are people who also like have the burden of migration across their whole organizations. And that's inevitably what this is all about. It's that like, sure, like I would prefer that like, I mean, like you're taught like, we're not on different sides of this issue effectively, like it is like in some ways a pain for me to have to maintain stuff for Python 3.6. But like I can't help you there, honestly. Like so we have customers who pay us money.
When Python 3.6 will be removed? Like, is there like a plan for this at some point?
Yeah, I mean, so like we keep bringing it. Like I've brought it up before with our leadership team, and our staff suites have brought it up before too. I'd say it's not extremely far off. Like it's not like we're gonna just keep this around for like 5 years, 6 years. But it's definitely like I wouldn't hold your breath. Like I wouldn't expect it to like happen until like say like Ray 3.0. Yeah, as Ray 3.0 would be released like next May, essentially a year from now. Yeah.
Okay.
Yeah, as difficult as that sounds.
So what we may be able to do then is to have Python 3.6 support to Jim and PettingZoo for the API only and not all the environments.
Oh, okay. Yeah. I mean,
Because for some of the environments that involve stuff with C, going and adding 3.6 is not going to end well. But we could do releases that add just like the core Python API that re-add 3.6 support. I mean, I don't. Here, Jet, Jet and Ben, do you have a sense of how hard this will be?
Nope, not yet.
Ben?
Depends what approach you take. Could just sort of.
I mean, the approach would be to turn Python 3.6 tests on NCI again and hit it with a wrench until it stops giving errors.
I mean, that would include all the environments, right? Because CI tests all the environments.
Oh, yeah. Okay, so fine. Figure out a way to turn CI on without the environments.
Yeah, I mean, we could just run, I suppose, have a CI run that just doesn't really test, maybe only test the subset environments which actually work.
yeah. I mean, if you could just give us
Oh
like,
yeah, we could do MP because they're pure Python and they're
right?
What?
Yeah.
Oh yeah, yeah. I was agreeing with was it Ben who was talking before this? Sorry. Yeah. It's like if you could just give us like maybe one or two environments that we could also like design easy tests around.
MP ones because those are very stable / old. So we can do so we can do 3.6 for the MP environments only. And we can probably do Python 3.6 and Gem for like classic control environments only.
Yeah.
Or no, toy text only. I think it would be.
Yeah, toy text would.
We can do toy text and classic control and Gem, and then do MP for PettingZoo.
Yeah, yeah. But like we could take like I don't know like some old environment that we've designed, and then we could also just wrap it in the Python 3.6 API, and we could. Yeah.
Okay, so provided that we can go and turn on.
I'm definitely not going to commit to it just right here and now, just because like this is a conversation that we need to have with Sven in June. But like they would definitely be interested to hear this. We've definitely not. I don't think like the four of us have had this conversation before. Yeah. So.
Yeah, definitely the whole team needs to discuss and agree.
Yeah. We need to talk about this one. But like let's actually like I'll see June like in an hour. Okay, I'll see June in like an hour and I'll talk to him and see what he says. Like, yeah, let's just like, I don't want to like, I don't want to get anybody's hopes up here, even though like I'm very much a fan of this idea. It would be easier in some ways, but I think like the trade-offs do have to be considered. The inherent like, so like another issue that I've been running into recently, like with maintaining Gem, not PettingZoo code, but Gem code, is that the most recent update somehow broke all of our, well, not all of it, but like it broke a significant amount of Cloud Pickle functionality, which was challenging to get.
But so the plan for Gem, and there's a roadmap for this, is that we're sort of trying to converge on sort of like a stable 1.0 package with a fixed API and fixed set of wrappers, because the set of wrappers in Gem are absolute dumpster fire.
Yeah.
And as well as environment overhauls. And in the update that we're about to release, there's going to be some more breaking changes. And then pretty soon we're going to get to the 0.5 release. And at that point, the base API should be standard. Mm-hmm. And the vast majority of the upgrades and fixes to the environments and just like random stuff that has to be removed is standard. The new final set of wrappers may or may not be done by 0.5. We'll have to find out. Mm-hmm. And then, but for the most part, most of the breaking changes will be done by this, and there's a roadmap for the specific things that we're doing. And then between 0.5 and 1.0, we're going to go and make and overhaul the vector environment API and make some other more minor things. And so essentially after 0.5, outside of the vector API, the number of breaking things should be fairly light. And we're trying to get this to like stable.
Is there a place where you could like potentially write down some of this, or like if it's written like maybe in a GitHub issue somewhere, like so we can like that would
that would be really
good. We need I don't want to misquote you in any way like when I go to talk about this with Sven.
And as far as PettingZoo breaking changes, for your knowledge, we aren't really doing anything. Like, PettingZoo is fairly stable. All we're doing on the PettingZoo end is updating things to sort of match what's been done in Gym after the fact. So like, they've got changes they've had to make for Gym. We've gone and are in the process of going and making the company ones for PettingZoo. At some point after all the wrappers in Gym are redone, we're going to redo them for PettingZoo to match the style that they'll be in Gym. Stuff like this. Otherwise, PettingZoo aren't making changes too. Really. Part of the problem with all the changes to Gym is, I don't know if you're familiar with the state of the code or a lot of internal logic. It is an absolute dumpster fire. It had a bunch of pieces of code that people depended on that like shouldn't have been there, and I mean, a lot of this.
Okay, sure,
Yep.
yeah. I mean, like,
The good news is this is being fixed, but it has to get to the 1.0 release before things stop changing.
0.5 release is the
Something
one
like
where
that.
things will get. Yeah, because
Even closer then.
doing the vector change is going to take a really long time, which is why we're going to have a 0.5 release, which is like a soft stable release.
Yep.
Aside from the vector stuff.
And a lot of it is because I'm getting internal errors.
This, Joseph?
Oh my gosh! I mean, like, I've had
more than 5.
Yeah, more than 5 at least. And it's just like people have just dropped off because it's just too much stuff to debug. It does not make sense.
No, I hear you.
Yeah. Which is, it's sad because like when you get everything working in RLlib, I mean, there's nothing close. Like, you guys have amazing tech there. That trajectory API that you have is so incredibly useful for some of this stuff. I mean, I was trying recently to replicate like some of the stuff you guys have for variable agent processing, and it's really hard. So if this were supported by like core packages like Gym and PettingZoo that people are familiar with and that can be tested independently and such, right? Like, I think that this would just ultimately be much better, at least for supporting academic stuff with RLlib.
There's an additional barrier, and it's that there's 80 different third-party environments that support PettingZoo right now. So there's something stupid, right? And like every single third-party learning library pretty much supports PettingZoo. And so what happens is that, so I am a academic or someone in the lab, or I want to do a thing with something that exists, right? And it supports Gym or PettingZoo. Apparently I'm using Gym and PettingZoo now because it's like HTTP, it's a standard interface. Yeah.
How about industry?
So yeah, that's where I will say is like within like we have like a duty to our industry users who like have like these really crazy and complex use cases. So like as much as Joseph, Jordan, like as much as I agree with you guys, it's like we still have to balance the two. Yeah. So like I think I do still want to try to answer Simon's question, unless Simon, you got to get going. But let's do one thing. I'll reach out to you guys like as soon as possible, like either inside like the contributors group or
and then also
I think
for us, the PettingZoo thing, if you can give industry examples of who's using it and would be interested in it from that side too, that kind of helps as well.
Yeah.
Industry wants. Here's the use case of that. It's sort of a flow argument. It's that academics, we're implementing all these fancy algorithms right now, right? We're implementing the latest state of the art. People are not implementing the latest state of the art on RLlib because it is hard and because it does not work with standard tools that the rest of academia uses. If it were easier to implement things in RLlib, you would have access to more high quality, state of the art, like cutting edge, just published in the last couple of months implementations for people in industry to use.
Yeah, I mean, Joseph, again, like this is the direction that we have been moving in for like the past 3-4 months now.
Yep. And you support academia in the process.
Yeah. I mean,
I'm just going to add more concrete. Oh, go ahead.
Sure, yeah, go ahead.
To speak of concrete industry use cases, I guess the industry use case comes down to, I want to, do X thing and test it on standard environment here, like the SMAC environments, let's say. Those are, in certain multi-agent contexts, is very standard. Or I wanted to test in the MPE environments. The only maintained MPE environments have the PettingZoo API. Those are very commonly used. Or you know, there's this really cool environment that does like smart traffic light management with the industry simulator, or that does power grid management with this simulator. And I'll use PettingZoo, so I want to test it on something that exists first. You know, or I want to test it on the UniML agents because that's super widely used. So the industry argument is, you know, well, if you want to use the thing that, like, you know, already exists, pretty much all of them, PettingZoo has kind of been the standard.
Yeah,
including like the smart traffic light simulator that the smart traffic light companies use has PettingZoo bindings.
Mm-hmm. Yeah, no, I like, again, fully in agreement with you. I guess, like, okay, like, to push back on you for just a second, like, is there a reason like why the PettingZoo wrapper right now would not work for them?
It is suitable for them.
Okay, it is suitable for them. But I guess, like, in the context of like what Joseph does, which is like the hard hitting limits of like what you would need in multi-agent RL, like, it does not work for him out of the box. And like, Joseph, the API does itself, but the API itself does, but like everything else that's around it doesn't necessarily. Oh, okay.
So I want to
Joseph,
the stuff that I do.
Really quickly, I want to say something. Joseph, we hadn't had this conversation yet, but we actually brought Ron on as an intern. I don't know if you know this. He sits next to me every day. He's very fun to work with, and he's going to spend a considerable amount of time on our side, helping you with adding like whatever testing infrastructure that you needed to add. Yeah, like that's what he'll be working on. Like,
that'd be awesome,
summer, actually.
Yeah. So yeah, I'm super happy to hear that. So that's great. Now, Avnish, I'd like to just one thing with Neural MMO. So right now, Neural MMO is this crazy out there thing that's doing tons of stuff, right?
Okay.
But fundamentally, what I'm trying to do is make it easy to do RL on complicated environments that don't fit into like the typical Atari model where you have a flat observation, a flat action, and like an MDP, right? This is the real world use case. This is the application that industry cares about. Like, it's just not standard, and we do not have the tools to support it, which is why nobody does in the industry. The project that I'm doing here, it is to make that easy and standard. So yeah, that is sort of the use case of like, oh, well, you know, only these really out there things right now really need everything. Well, the really out there things, the point of it is to make it possible to actually run RL on environments that you would see in the real world that do not have well, for all intensive purposes, that are not Atari.
No, I totally get that. And most of our customers don't do that.
Don't have Atari, right?
Yeah, I mean, most of our customers, like,
thus far though, right?
You know,
like, it's an expanding industry.
Native PettingZoo bindings.
Sorry.
I mean, so if they're in the video game industry, like UniML agent has native PettingZoo bindings, for instance.
Yeah, but I mean, I guess, like, to maybe shed like some perspective here, most people don't use Unity ML agents. Like, they have.
I mean, there's a lot of. I don't know about. Sorry, didn't mean to interrupt you.
I mean, they do, but like, they typically have like custom game engines, and then they need a way to interface with those game engines. So it's actually like a relatively undecided space in that sense. Like, people are just starting to get into it. Yeah.
So anyway, we've grilled it for long enough. I don't mean to.
No. Yeah. I appreciate you guys like coming here and like us like getting to have this conversation. Yeah.
Let me just mention one thing. That's your question. You asked, isn't the PettingZoo wrapper adequate?
Yeah, for like the majority of users. Like, I like that is like the one thing.
Yeah. So the PettingZoo wrapper, if you want to just like take parameter share PPO just out of the box and plug it into a PettingZoo environment, then it's adequate. However, if you want to like modify an algorithm or like, you know, do more complex learning things, which I'm going to go out on a limb and say a lot of your customers probably are doing, then switching to the PettingZoo API instead of the internal one becomes much easier.
Yeah. Okay. I mean, I definitely see like the case for that argument. It's like, if people start using PettingZoo environments and all of a sudden those PettingZoo environments like can't interface properly like with our algorithms, then that would be definitely difficult for us. Yeah. Okay. So here's what
Okay.
you could do for me, by the way. All right.
Yeah.
So like, I think like one thing that's made the discussion like not fruitful for us on like the RLlib end is just that like I know you did tell us like in a meeting back in like October, November, hey, we're gonna make like certain changes, and you and I even had a conversation about like changing step type and done type, right? But like to have the written list somewhere and like a rough dates by which the changes would land, that tells us a lot about like how we can do like our own developer iteration around what you guys are doing. So I'm not sure if you're a part of like our RLlib contributors group, like on Slack, but I know Joseph is. Yeah, I'll add you, but I know Joseph is, and Joseph, like if either like you or Joseph could just like come up with this list, like just roughly speaking on like the dates, like we actually have a meeting about like strategy discussion like internally at 10:30. So like if you guys like have this list anywhere, or like if it would just like any bullet points, it doesn't have to be like super polished. But like,
the list exists. It needs to be cleaned up slightly. I'll go do it now and send it to you.
Yeah, but like if you're comfortable with just sharing like this rough list, like that in itself, like
I need to do a like very small amount of cleanup and then I'll share it.
Okay, yeah, all right, sounds good. So like yeah, if we could just like have access to this list, like we can, if you can get it out to us by like 10 o'clock, we can have the discussion like today, and then if not, it's fine. We'll just have the discussion.
It's 9:10 at your time.
Yeah, it's 9. Yeah, it's so 10:30 is like when we have to meet. But
I'll give it to you in like 10 minutes.
Oh, okay, great. All right, yeah. So yeah, we were actually going to have this discussion today, anyways, because we were having some issues on our end.
I mean, like to sit in on this, we can. I don't have anything in half an hour. If that's helpful.
Okay, so I think maybe we'll talk about doing that next week, but like just for this week, I think it would be a little bit too early to talk to Sven about that. Yeah. Also, this is a larger meeting, like with some of the Swedes in our company. Yeah. I mean, but like I'll be real with you guys. Like to shed light, like we're at a point where we could go two ways. We could either like double down and like really integrate with the gym and PettingZoo APIs, or we could go in the direction of like really sticking to our own APIs and then having wrappers like so that people can interface like through their own environment with our own APIs. We do have like a different set of challenges than you guys. I do understand that like you guys like are making like great software, but like we have to think about like actually the whole end-to-end life cycle, like ML life cycle. So like, there actually are like some other issues that we do run into like in terms of like how it is that we would actually serve like say a policy that was built on top of I don't know gym spaces and things like that. Yeah, so like some of these things are going to play into factor, but like the one thing that I can say though is that like I will very sincerely make my best attempt to like keep you guys in the loop so that you guys can make your own decisions based off of what we're doing. Like if there's anything that you want to change, we definitely won't have any big asks of you. I think that would be like very unreasonable considering that you guys are academics and you guys still do need to graduate with your PhDs. Here's rooting from you.
We can probably add 3.6 support, at least. But we can probably re-add partial 3.6 support.
Okay. Well, yeah. I think like I don't want to make it about that specifically. That's just like one issue that I've dealt with. Like, but we can very honestly like give you like a list of things that we would have to deal with, and like, yeah. So, I mean, like if we think that like we can do the migration and like be successful, then like I don't see any reason why it can't happen. Yeah, if you can get me that list, that'd be great. And then like if you have like something roughly similar for PettingZoo, that would also be great. Yeah. And then
PettingZoo, it just whatever happens to Jim 2 months later.
Okay. All right. Awesome. All right. Cool. So
and then I just add, since we are open source, feature requests to GitHub issues would be really helpful to document.
Yeah. So we had a GitHub issue for Python for the newest version of Gym. Yeah, that was closed. I believe there's a PR created for it that's been it got left open for
Jordan. It got merged. Like yeah, we were having issues doing the upgrade into something on our end, or like on Gym, or like on.
It just hasn't updated in a few weeks, so I'm going to fix and send you the list on Gym.
Oh, awesome! All right, cool. Sounds good. Yeah. Okay. Okay. I know we're over time, but like Simon, if you're still here, I do want to answer your question. but I'm gonna rush through it if that's okay with you.
Thank you.
That's fully okay.
Okay, so Simon's question is about how to implement DDPO with TensorFlow, right? Okay, so like the way that we do it right now, I wouldn't recommend trying to do that also for TensorFlow, but there is a way to do it using RayTrain, actually. So RayTrain is like our distributed deep learning library. And it just like provides these nice and easy to use wrappers around like TensorFlow distributed and Torch GDP. And yeah, so I've actually like before you had submitted your question, I had actually given your question quite a bit of thought, just because like we've been trying to migrate essentially all of our training backend to using RayTrain, and like we're in the process of doing that right now. Okay, so RayTrain has a way in which you can create multiple ray actors that have, say, like multiple neural networks on them, and you can like connect all these neural networks like via like TensorFlow distributed. And in the case that you do that, whenever you do like a parameter update, you'll be like accumulating the gradients across like all of your different neural network parameters. In a nutshell, like what it would look like is like you create these RayTrain actors, and on each one of the RayTrain actors, you would create a PPO worker on each one of your RayTrain actors, which has the ability to sample and update from like a set of samples. And then you would link these PPO workers, like each one of them has like an underlying TensorFlow model. You could link it by using like this with tf.distributed scope strategy with context scope object that they have. And then, I mean, the only difference between like regular PPO and DDPPO at that point is you collect samples, and then like you have some like coefficient that basically checks to see like, okay, like for every one of my distributed workers, I'll wait until like N% of them are done sampling, and then I'll like just do a parameter update with whatever I have. So you like implement that, and then when you go to do the training update, it looks the exact same on each one of the workers as it would outside of like using RayTrain. Like you would just like, you would call learn on batch with your batch like from that's collected by the same worker. And then that in theory should do the entire update. So yes, it is possible. Is there a reason why you want to implement DDPPO on your own though, Simon? I'm just like curious.
So actually, I want to use that for my exploration algorithm.
Yeah, okay.
And Sven suggested me to take a look at the DDPO. And that's why I got there.
Okay. And then is your exploration algorithm in TF?
I have both. So Torch and TensorFlow, and I would like to parallelize it with also both Torch and TensorFlow. And I need the same form like used in DDPPO, because I have to like update the model after each episode.
Okay, I see. Yeah. So have you tried doing it for Torch right now?
No, not yet. I was more into DDPPO to see how it could be done with TensorFlow. And so I've not yet tried out with Torch, which should be easier. Definitely.
Okay. So, but is it a requirement for you, I guess, for it to work in TensorFlow for the time being? Is that a requirement?
I would say it's not a requirement. It's something I would like to see, because I'm more used to TensorFlow than Torch.
All right. I think what I'm going to do is I'm going to inspect a little bit more like the multiple ways that you can do this. But I'd say for now, like, just because like your idea at its core is like, I mean, I guess you already implemented novelty, so it shouldn't be too bad to go from like, you know, you've implemented novelty to now you have to combine that with DDPO. But like, I mean, like from engineer to engineer, like do the low risk thing here. Like just test that on Torch first, you know, and make sure that's the direction you want to go in. Just because, like, yeah, you'd be investing a lot of time, like trying to get that to work. Yeah.
Okay, that's at least a point with which I can work. So I go first for Torch, that I know that the other one is really like complicated.
I feel like you have your own you have your own priorities, you know, like with respect to your own work. So I'd caution you against doing this.
Okay, but it's a clear statement. So thanks for answering my question.
Yeah, I'm gonna link to you like just like I'm gonna link to you the PR that I did for distributed Torch like policy gradients algorithm, so that you can take a look at it. I'm not sure if it's going to be really helpful to you in this case, but
yes, please. So
yeah, I'll give this to you.
I definitely want to take a look into it.
I think one thing that is nice though is just like it just is very simple compared to what was there before this. Okay. Does anybody else have like any higher level questions? Christy, is there anything you want to say too?
No, thank you. Avnish is a really big office hour.
Yeah, I have a really, really quick question.
Yeah, sure. That's good.
Yeah, so currently, as you knew before, I was just working with PPO, but I'm working on a multi-agent algorithm that just like it's very, very hard to train on. Like I've been trying to get good policies on it for like half a year now, and it's PPO is not working out. I'll phrase it that way. And I've tried some other algorithms and did some basic hyperparameter tuning, not working out either. What algorithms would you recommend? Recommend looking at?
Okay, can you talk about like the state space of your problem first and like what it is you're trying to solve?
So it's called the Fort attack environment. There's a variable number of attackers and guards. It's a discrete it's like a discretized environment, but like the environment in actuality is continuous.
Okay, you've approximated your actions and your observations as discrete.
Yeah, so you can. This is what they look like. In another paper, these look like trained policies. They're really not. Like these actors, like the guards learn to kind of just do the same thing across each episode, and the same is true for the attackers. It's these policies are trash. So I want like actual reactive policies. One of the other things is you can see these never turn. Like the action spaces is essentially move in one direction, shoot or turn.
Okay. What's your or turn? Okay.
Yeah, and
what's your reward function look like? Because I think that's the big deal here. It's like, so you're working on this environment and like sure these policies are like kind of bad, but like
I've been doing a lot of reward shaping, and
you've been doing a lot of reward shaping. Okay.
Yeah. So at the beginning, it was just whether a guard hit an attacker and whether the attacker reached the fort or not was the big thing. I've added essentially whether an attacker is facing the guards, how far they are away, just like as proxies. And that has enabled turning, but like I'm able to get good policies for 1 or 2 agents, but beyond 3, I'm not able to get anything.
Okay. All right. So couple things. Okay, I used to do like RL and robotics before I was doing this. And one thing that I do know is that like if you can essentially write a controller or like a scripted policy that like performs the sequence of like actions that is necessary in order to like, you know, complete this task, then like then it means that your environment is solvable. Okay. And like it's just a matter of like coming up with like a nice reward space that's like continuous and like not too jagged and doesn't have like too many varying different slopes. Okay, so that's the first thing. Yeah, the second thing is like it sounds like a problem of scale. I think like in the sense where like you can do it with 2 actors, but then as soon as you get to 3 or 4, it kind of falls apart. See, what's difficult about this for me is like you have access to the environment, so you're not in a situation where like you have difficulty with the number of samples you can collect. PPO is like extremely efficient in 2 cases. In the cases like where you have like a reward function that's like a little bit sparse, or like there is, say, like some partially observable quantity in your environment. So I don't know if there's any partially observable quantity in your environment, but I imagine that there could be.
I mean, multi-agent is inherently partially observable, right? Because you don't know what the actions of the other agents are going to be. But like, that's semantics, right? If you're not talking about that, yes, it's fully observable in terms of what the agent can see. The raw,
well, it's just,
the
I
raw
guess it's just for
state
that
space.
reason, though. Yeah, I guess it's just for that reason that I'd say like stick with like PPO, APPO, DDPO. Like all these algorithms like should help you get to where you need to go. What happens if you like take a policy like for like say 3, 4, 5 agents and like you visualize it? What happens?
Define visualize.
I mean, like you can create these cool visualizations here, right? I'm assuming there's like a dot render that you can.
Oh yeah, when the rendering, they just kind of like look around and don't do anything. I can try to get an example.
No, that's fine. I think I actually like as cool as it would be to look at. I'm not sure if it would help me in this case, just because like I'd have to be a little bit closer to the problem to understand.
Yeah, I guess the point is that the reward function does not even slightly converge. In fact, it gets worse because one of the other behaviors that I noticed is that the guards just learn to not shoot at all. And that's because I give a slight negative reward if they don't hit anything, essentially. And so
okay,
the issue is if you don't give them any penalty, they'll just fire randomly. And
no, that makes sense.
If you give them, yeah.
So Renos, the other thing that I would recommend to you is like so in order to get PPO to work really well, it's like not as well a known fact, but like you do have to do like the thing that makes PPO work in like really complex state spaces is entropy tuning.
Okay.
Yeah. So like if you open up your TensorBoard, like I'm not gonna ask you to do that right now. And also I have to get going because I have to meet Sven in 30 minutes. But
yeah, sure.
So there's this coefficient that you can tune called your entropy coefficient. Okay. Yeah. All right. Maybe I'll just give like the one-liner, which is like, yeah, the one-liner is like basically what we do is like for every single like reward return that we evaluate, like when we're like doing our loss update, we essentially like we add an entropy penalty. So the entropy of an agent like is essentially like controlling its likelihood to take actions that are outside, like that are far outside of its like probability distribution. So you want like high entropy agents typically in general, like when you're using PPO, because high entropy agents would lead to essentially like a better explored problem. So like when you tell me that like your agents like aren't learning to do anything, well, like your reward increases in magnitude, right? When you increase the number of agents, right? Like the reward range. Sorry, the reward range.
Right. Oh, that was another question. What reward range would you recommend keeping it in optimally for the algorithm?
Yeah. Okay. So this is like something that just relates more to neural networks, but like I'd say basically per agent you could keep it between like 0 and 1 or like 0 and 10. 0 and 10 is like a little nicer, but like getting into the thousands is like kind of not a good idea, just because like you have to like deal with essentially like all these gradient regularizers and gradient clipping, and then you have to like really be careful about how you tune. So this entropy coefficient directly relates to like your basically what they do is they take
see it
like,
in the list of PPO.
It's called like an entropy. Maybe it's not in there, but it's called an entropy coefficient mixin. It's definitely an APPO and IMPALA. You can definitely tune this. It also might not be directly in PPO. It might be in one of the algorithms that PPO inherits from. But if it's not in there, then like, and you don't find it, just like open an issue and I'll like very quickly implement it.
Sure.
You wouldn't see it inside PPO.py though. You would see it inside of the PPO policy. Yeah. Okay. There it is. Okay. So with this entropy coefficient scheduler, you could try messing around with this first. I'm not sure if like this is the same thing as like passing like an explicit entropy, but in a nutshell, like what this is going to do is like this parameter over here will control your exploration, and like what you're looking for when you like go to open TensorBoard on RLlib is that this parameter, if it like collapses essentially towards 0, like on your TensorBoard, if you search up entropy, if it collapses for 0, essentially what that means is like the average standard deviation of like any one of your policies is extremely low, and it's not likely to explore essentially outside of the mean action taken by the agent.
Mm-hmm. Right.
Yeah.
That makes sense.
Yeah. So like that is like the most important thing to control when you're doing like this on policy RL. Yeah. So if you're telling me that like you increase the number of agents and like you're not seeing like the reward go up, it probably means that it's not
It goes
explored.
up a bit and kind of overfits to not shooting and then like trying to kind of look at some of the agents, because like a lot of the reward shaping I did is making sure that it like is kind of close to and kind of looks at least one of the agents, because that's a proxy for like being able to shoot and kill it. So what it does is it learns not to shoot, and then it just looks to like just look in the direction of the agents, which and then it just flatlines essentially with reward, because obviously that action is very suboptimal.
Yeah, but essentially what you're describing to me like pretty much tracks with like your exploration is like not going particularly well as you increase the number of agents.
Yeah, the max the min reward is a lot lower than the max reward is high, because the max reward is just whenever you kill an agent you get 3 points, and then if there's no agents left everyone gets 10 points, although I disabled that. So
okay, so that's actually also bad. You should keep like you should make the penalty for taking a negative action basically the same as like how good it is to take a positive action, or like even less than that in terms of magnitude, but not necessarily direction.
Mm-hmm.
Yeah, these are just like lessons that I have learned from writing like reward functions for like these complex robotic manipulation tasks. It's like, so I'd go ahead and try that out. Like maybe don't change your reward function first, just because like there's a lot of changes to a blade. Maybe just first like open up some old TensorBoards and then like see if
look
like
at
you're seeing, look at entropy. See if like you're seeing a collapse. Like if you see it basically like I don't know if you can like see my hand, but like basically see it go up like this and then like essentially like
right,
just absolutely collapse to 0, then like that would be indicative that like you're seeing an entropy collapse. Something that you can do also is like just take a screenshot and then post it in the RLlib channel, and I'll take a look at it when I get to it. You just tag me in it.
Sure, sounds good.
Okay, cool.
All right, thanks a lot. Right. I know this went very fast, but
thanks for all the great feedback. Christy, sorry if we kept you over too. My bad.
Yeah, it's okay. Yeah, thanks, Avnish.
Yeah,
thank you very much.
Didn't know this was going to go that long, but yeah, it is. It was good. Yeah.
Okay. Thanks, everybody.
Okay. Bye, guys.
All right.
All right. Bye.
Bye.
Bye-bye.